Welcome everybody, you're watching Mr. Fugu Data Science. Today we will install Anaconda on a new device as well as show a few useful commands to get you started. Feel free to leave a comment to help others. Anaconda is a package manager featuring hundreds of libraries or packages useful in scientific computing and machine learning. If you need more of a streamlined download without all the packages, consider using 𝗰conda, which saves space. 𝗰conda allows you to add as you go without all the overhead or the GUI interface. If we go on to Google and look for Anaconda, we will see anaconda.com is the webpage. When we enter and look for the download section, choose the appropriate version for your system requirements and decide if you would like a GUI interface or just a terminal-based approach. You'll be greeted with an option to register your email, but you simply could deny this. It's not really necessary for the download portion. I want to mention that there are two alternative ways to download, such as Homebrew Package Manager or using a curl request in the terminal. I would like to discuss two distinctions that come up when you decide to download Anaconda versus 𝗰conda. Real quick from the documentation, the differences between both. We'll see that the file sizes go from being multiple gigabytes to less than half a gigabyte, as well as a huge discrepancy in the number of packages that are offloaded using Anaconda versus 𝗰conda. A great thing with using Anaconda is you have the Jupyter Notebook, which is a visual representation. You could code, you could collaborate with others, use it for presentations, which I've done quite often. Just depends on what your use cases and your needs. Using Anaconda Package Manager has a few benefits, such as creating different environments and version control. If we were downloading all of this globally across our device, this would be problematic later. For instance, collaborating with others or creating projects with certain dependencies can create a snag later if you're stacking multiple versions or overwriting older versions, which may not be compatible with all your future dependencies. You have other abilities such as using 𝗺env or venv to store your virtual environment and manage your packages. We're also staying away from system processes such as the default version of Python on Mac. This is used under the hood to run certain tasks in the background, and you don't want to start messing around with this and updating or changing the configuration of Python within it. On an older device, you will see a default to Python 2.7. Instead of globally updating this, think of it like this. You're trying to help yourself, right? Do not mess with the system at all and consider creating a virtual environment to store your work and use whatever package manager you like. In this case, I'm using Anaconda. After we do the download of Anaconda and open the terminal next to your prompt name, you may see on the left-hand side something that says base in the parentheses. First, environment, let's store through Anaconda, which houses all your dependencies to get everything working for the program initially. When you're creating your own projects, you have to create your own virtual environments because otherwise you start updating this and it will mess up everything down the line with conflicts. Running the command which Python will show you where the Python is stored within Anaconda. To find out what version we just downloaded, you could use the command python -version. I just downloaded this recently and it was 3.12.2. To exit out of the conda environment, you can do conda deactivate, and this will get you in the normal shell with whatever working directory you have your system formatted to. To go back in to the environment to work in Anaconda, you would do conda activate. If you want to activate a specific virtual environment, you say conda activate and then type the name of the environment that you want to enter. To find out if by default conda is activated when you open a terminal, run this command conda config --show, then the pipe, and then grep change ps1. Mine says true, so I have by default the ps1 variable set up for the conda environment. To show what environments we have, we could do conda info --envs, and it shows that I only have the base environment currently because I have not started it. If you are not in a conda environment and you want to go into a Jupyter Notebook, you're going to see this error. It says conda not found Jupyter. So we have to now open or initiate an environment by doing conda activate. Now we're inside of conda and type Jupyter Notebook and it'll open up in a browser window for you. If this is the first time you've seen the Anaconda Navigator, just find it in the Applications section, and it'll be at the top for Anaconda. If you noticed right here where it says base root, that is our environment that comes pre-installed with Anaconda, storing everything that's necessary to get this running. This base root is not what you want to start installing packages upon. We will create other environments that will come in the drop-down window later, where we'll continue our work and create our projects. When I create my demonstrations, I use Jupyter Notebook or for little tutorials. You have other options available. You can utilize RStudio inside of Jupyter Notebook if you have RStudio already available. You just have to do a few commands. Here's some other options that you have available. Before we do that, you can connect if you have an account. Here, let's open this up. And now we have Jupyter Notebook opened up. We can use the terminal. We can create a new Python file, which will be going inside of the base environment. Let's go back to the terminal and let me show you how to create your own environments to have your own workspace and avoid conflicting errors later. Creating an environment has advantages. You're isolating your dependencies and making your code reproducible for people you're collaborating with, as well as if there's future updates that cause conflicts, you're basically storing this in a container that has all the original dependencies, so it should work over time. You're managing packages and libraries that are self-contained with CRUD operations. It's great for testing and deployment of projects because it's also self-contained. Before we start jumping into the terminal, creating an environment's pretty easy. You just do conda create and then --name. But this needs to be without spaces here because you will get an error. I did this for illustrative purposes. And whatever name you want that's meaningful for you for your environment's name. If you needed to add a package or something with a specific version number, you can do it just like this. You could do it all at once if you want for this whole line, but you can add a specific type of Python 3.8, for example. You could activate and deactivate based on a specific environment. Conda list allows you to find all the packages that you have installed for Conda. You can look at the environment list and see what environments you have, your current environment information, as well as updating packages just by doing conda update and then whatever package name is, as well as installs. And if you need to remove a library or package, just do remove and then whatever its name is. Let's go into the terminal. If you have any spaces here, it's going to give you an error. Make sure it's together for whatever meaningful name that you want. I'm just going to say my first project. It's going to ask me, do I want to create it? And it's going to store it in this location. So let's create it. Now it just created it. We can activate our project by using this command. And then to close out, we can use the command of conda deactivate. So let's try that out real fast. So this just, I'm lazy. Now, if you see, we're in the new environment that we have, but let's do conda list. And we don't have anything inside of it. Conda info envs --envs. Now you see what environments we currently have. We have the base one and the first one that we just made, and that's what we're currently in now. If you need to add a specific version, you just do Python, for example, conda install Python 3.8. And you could just put a space and add whatever you want, numpy, whatever, 3 point, whatever, to get that started. So let's clean this up a little bit. Let's say that we wanted to install pip, but what happens if we wanted to do an update on something? You would just do conda update and then whatever package here. For example, numpy, Python, scipy, whatever it is. And everything that you would be using would be within this project, this environment of my first project. Now that we have an idea of what to do, I will actually install 3 packages into my first project, which is our first virtual environment in Anaconda. You can specify directly what versions you want for these if you need a specific version for version control. Here, I'm just illustrating a few basic commands to get you started. Let's go. That was pretty darn fast. Let me say yes. Downloaded everything. Everything's done. Let's look at everything that was installed with this, with all the dependencies. Let me clean this up. We can also do a remove or uninstall for a specific package by just doing this. And we could do a remove if you like to remove it. And then you can just say yes. If you notice in here, you see all of the dependencies. You see pandas is involved and then some Python utility functions as well. That'll be the conclusion of this video. So feel free to like, share, and subscribe. And if you subscribe, turn on that notification bell. If you would like to help support the channel, I have a buy me a coffee. I'm not sure if super thanks are available right now or my Patreon, but it'd be greatly appreciated. Leave comments in the comment section below for any video topics that you would like me to cover in the near future. I have 2 quick videos for Anaconda that I want to mention soon, and then I want to get back into coding if possible. Thanks.